All right, for today, guys, we're going to continue our discussion on Chapter 11. I do want to show, again, our due dates for those that maybe weren't here on Tuesday. We're looking at April 16th, which is next week, Tuesday, for the homework assignments. I'll touch on problem 40 toward the end of the discussion today. It's not a hard problem. It probably will take most of you just about 30 minutes to complete. So it should be pretty straightforward compared to Chapter 9's lengthy problem. So that'll be a nice break here for us. Going back to our discussion from Tuesday, we were working on problem 42, and we were showing how we can use these performance measurements to decide if we want to do a project or not do a project, and that's what problem 42 showed. In this case, if we remember from Tuesday, we should do the 15.2 turbocharge because its return on investment is greater than where they are now, which was 15. So a slight improvement, not much, but it did show some improvement. Now, also found we did a residual income computation. Now on Tuesday we did a 14% company margin. In the second half of that residual problem, they want us to use, instead of 14, they want us to use a 10%. So what I've done, instead of having us compute it by hand and doing it in class, I just wanted to do it beforehand and provide a overview of which scenario now is best for this particular company. And as it is now, the best choice is to do both investments. If you remember from Tuesday, with a 14% company minimum rate of return, the best choice was to do the turbocharge only. So that's where we were on Tuesday using 14%. Now, by changing the company's desired rate of return from 14 to 10, it's better to do both investments. Both the turbocharger and the air conditioner. As you can see, with a 10% minimum, obviously the 12 from the air conditioner is greater than the 10, and obviously the 15.2 is greater than the 10. So that, again, proves out that they would both provide additional income for the company if both projects were taken on. So that's why here you can see that the 1.488 million is the largest residual income amount. So that's why it's best here. So I guess this proves then that basically, depending upon the company's desired minimum rate of return, so this is defined by the company, makes a huge impact on whether or not a project is taken on or not. So these different scenarios can be played out and analyzed to see what the company should do going forward. So are there any questions on this second half of the residual income? Again, I'm not expecting you to take the notes down and have these all in your project. Obviously, these notes are saved in a PDF file. If you want to write down the numbers, you certainly can. And if you have any questions, just let me know. Hi, Allison. Welcome aboard. Who else do I have here? Oh, Miley. Hi. Welcome. That's all right. Hi, guys. Welcome aboard. So, going back to our overview of Chapter 11, the author then on pages 603 and 604, they talk about the advantages of using the residual income as a performance measurement technique or performance evaluation. And there are advantages, and the author talks about accepting any project that earns a minimum rate of return, and that's what residual income does. If the company's minimum rate of return is 10% and our project gives us a 12% minimum rate of return, well, obviously the residual income is going to be greater than 0. So that's, in a multiple choice question, could easily be asked and determined. So be aware of those, I guess, word definitions for residual income. What causes residual income to be positive? What causes residual income to be negative? If we could reverse order here, we could say if the company's is 10% ROI and this project that we're considering is only going to yield an 8% return on investment, well, that would lead us to then say our residual income would be less than 0, and then obviously we would not do our project then, right? That's the main reason we're doing this computation, is to see or determine what projects we should take on and which ones we should not. And obviously with advantages, there's always disadvantages. With any of these ratios, always these residual income and return on investment computations really kind of force the manager to look at only their short-run projection within the year versus maybe a 5 or 10-year outlook. So that's one disadvantage. Also, return on investment, unlike a return on investment, the RI, residual income, is an absolute measure. So projects with larger dollar amounts have an advantage. You know, they're capable of producing a lot more revenue or cash flow, so to speak, than smaller projects. So the bigger ones do have an advantage. So that's mainly the big disadvantage with residual income. And we can get different results, obviously, between ROI and residual income. So you could have a scenario where ROI would be good and residual income would say not good, or vice versa. So that's, again, where you could come up to an impasse and not be able to make a clear decision. They do talk about competing projects, so I need to find that. I'm not seeing it in my notes. Let me see if I can find it further in my notes. When it talks about which is best, residual income or return on investment. And I could even be thinking about another chapter. Well, let's just put this down, just in case. ROI is the measurement most often used by companies. In their performance evaluation. So know that, please. ROI is the most common measurement of performance evaluation. And I want to look at competing projects. I might have to look for it and let you know next week. Because I just don't seem to find it. Yeah, I guess I just don't see it at this point. Let me make a note here. What I'm trying to find is whether, when I have two competing projects, there's a test question as to which of these two measurements would be best to choose the correct path for the company. And I believe, I thought it was residual income, but I just don't see that comment here. So that's something I'm going to have to follow up on for next week, Tuesday. All right, so our third performance measurement is economic value added. This discussion begins on page 604 of our book. It's very similar to residual income. In its computation, we're looking here down below, it's after tax instead of before tax operating income. And also different is that we're going to use the actual percentage of cost of capital. And this cost of capital here, percentage, is really the loan percentage or borrowing rate. The loan percentage or borrowing rate is what we're going to use for the economic value added. This is the measurement technique that Terman Miller used to help its managers look at this number and improve this number by reducing their cost of inventory. If you remember in the article, they had a downturn in their sales because of the economy. They decided to cut costs, and one way they could do that is to reduce their cost of inventory. So this measurement then was used to decide whether the manager did that, whether they were able to reduce that cost of inventory. If we remember from the residual income, the RI is before tax operating income minus, parentheses, the company's minimum rate of return times their capital employed. Or assets. To generate, obviously, that income, right? So that is in parentheses. So what's the difference? Well, this is after the tax, this is before the tax. This is a cost of capital or loan percentage versus a company minimum rate of return. So you'll have to do both computations, obviously, for the exam. The exercise or example for this computation is example 3 on page 605 of our book. They're looking at income after taxes, which is this 33,600. If we were doing residual income, we would be looking at the 48 number. And the problem states their borrowing cost is 10%. So that is used instead of the company's minimum rate of return. And it's just a very similar to residual income. We take our after tax minus 10% of the capital employed, which happens to be 300,000. So we have a positive economic value added of 3,600. So in other words, not only did we meet the, we had net income, we also had a positive economic value added, which improved the performance of this company after taking out the cost of that capital. So, which was 10%. So if a company can reduce their assets, which Herman Miller did, in the value of its inventory, remember inventory is considered an operating asset. Let's start over. Didn't spell inventory right. If we reduce the inventory, we reduce the assets, which then can improve our economic value added because we're multiplying against a smaller number. And that's kind of the goal here with this EVA computation. We only have, I think, one problem to try this on. It's problem 30. So let's just jump to there. On page 634. We've done this problem already for, I believe, residual income on problem 32. So numbers we have are given to us. Oh, I should do the next one. I guess I do have two here. Let's do them both. They're really quick, guys. Problem 30, Falconer. After-tax income was $12,375,000. So EVA equals the after-tax operating income, $12,375,400. I'm going to subtract, right, in parentheses. The cost of capital in this case was 9%, and the total capital employed was a huge number, $111,754,000. So I'm going to simply multiply the 9% times the cost of capital employed, which is basically our operating assets, right? That's what we use to judge whether we've used those assets to its fullest capability and make money at it, right, to generate enough revenue for it. So 9% of 111,054,000 is 10 million. So I'm going to just write this number down again. And I'm going to subtract the 10,057,860. Did I make a math there? Did somebody buzz in? Very good, Allison. Thank you. That's what I came up with. Excellent. 10,057,860. Allison, what's my EVA then? I know it's a big number to type in. Great, 2,317,540. Is the EVA. Now here again, it's a positive number. So they've earned more than their cost to finance those assets. So in this case, a larger the positive number, the better. You've made more money on those assets, right? So that's the goal here. And with EVA, the author has us decide whether they're creating wealth or destroying wealth. Well, if it's a positive number or positive EVA, we're creating wealth. If we have a negative EVA, we didn't make enough to cover the interest expense, right, from the profits of the organization. We have a negative EVA, we are destroying wealth. So you'll need to know that for some of those simple multiple choice questions regarding EVA. Another way we can use EVA is a analysis. So let's just do 31 quickly here and use the numbers provided for Adams and Jefferson. And let's start with Adams. We're at 605 for the after-tax income. Minus 12%, right, cost of capital on $4 million. I believe that's 480,000. So I'm just going to come down. 605 minus 480,000 gives us 125,000. If I carried my numbers correctly. 125,000 EVA. It's positive, right? So we are creating wealth for the company. We're creating wealth for the company. And let's look at Jefferson. They are at a EVA computation of 315,000 minus, again, the 12% cost of capital. The capital employed by Jefferson was $3.25 million. And this one I'm going to need some help on. So let me know, guys, what you came up with. Get rid of this. 3,250,000. Had my commas in the wrong spot. So what's 12% of 3,250,000? Anybody at home have that? Or here? 390. Thank you, Carla.
I agree.
390. Chris, do you agree? Excellent. Yep. So we are actually in a negative situation here, which obviously would make it a negative 75,000. So in this case, we are destroying wealth. So in other words, this particular division, Jefferson here, has the opportunity now to make a change. So we need to determine what can Jefferson do now to improve this EVA, right? And this is something that Herman Miller was looking at. How do you improve this to get this to a positive number? So what is one way we can make our EVA better? I talked a little bit about it beforehand. Anybody at home? Yeah, very good, Allison, from the bank world. Yes, we can find a lower interest rate, right? So that's certainly something I would do. Very good. Because again, 12% seems a little high in today's world anyway. Maybe 15, 20 years ago it wasn't, but in today's world that's certainly a very high rate. So that's one thing Jefferson can do. What else can they do? Anybody at home? Yes, and along with increasing prices, Allison, very good, is you could always reduce expenses, right, as another means of helping out. So increase revenue through means of maybe a price increase or reduce expenses. And what's the final thing that we could do here? There's one more thing that we can do here. Anybody at home? What's the final thing we can do here? And what did Herman Miller do, actually? Anybody? Punting? Are we punting? I believe Herman Miller reduced assets. Reduced the level, the amount of assets. And they did that through inventory reduction. And that was the goal here. Because again, it's very expensive to carry inventory, plus store it, plus keep it from getting stolen, plus obsolescence that we always have to worry about, or damage within the storage area. So all of those costs are a huge burden on a lot of companies. So any type of asset reduction, in other words, make this 3 million, make this 3 million something smaller by getting rid of, reduce assets, or reduce equipment, right? Not used. So that's the goal here. So it's a nice way to analyze a company's performance month to month with just basically one number, EVA, for that particular division. So hopefully that should be an easy computation. Any questions on any of those particular items here at this point? Silence is good, I think. Hopefully. All right. Are we all happy?
Yep.
So I'm going to send that out. I'm assuming we are. Okay, let me know. I do want to jump, guys, to our project problem because we've covered everything necessary now to do the problem. So it is problem 40. If I could have you turn your book to page 637, please. Page 637. Like I said, this problem will be a lot easier than the last chapter 9 one, so it's kind of a relief in some regards. It should not take you very long to do this particular problem. Okay, here we go. I believe there's basically 6 questions here. And maybe it won't show me now. There it is. Here we have an analysis on a particular division. A question? Sorry guys, I'm getting... Oh, no. Actually, no. I don't have... I have Monday yet, Carla. So I'm not quite done with chapter 11. And I also have a pre-test I want to go over on Tuesday. All right. For our project here, it's very similar to problem 42 in that we've got to compute ROIs under 3 different scenarios. The division without doing the project, which is our radio project, just the radio project itself, and then if the radio project is undertaking. So you will use these. They first had $725,000 of income with operating assets of $3.6 million. Their new investment is actually more, as you can see here, $640,000 of income for an additional investment of $4 million. There's actually more investment going in than what they currently have for assets. So initially it's just by itself, then it's by the project by itself, and then finally it's together. Both incomes added, both assets added to come up with a total. And you do the same thing for the residual income computation. The company's desired rate of return is 12%. Now, I'm looking for rounding, and I don't see anything regarding rounding. Oh, here, percentage to the nearest whole percent. So that means no decimals, right? It's 10% or 12% or whatever the case. And I believe then that the residual income is to the whole dollar. So no cents again, whole dollar, and those particular answers. So that's it. That's the whole project. Again, it shouldn't take you long. You can probably do it while we're talking in class here. So let me know how it goes. All right. Again, there's advantages and disadvantages to EVA. This is talked about on page 606. Please, if you get a chance, there are checkpoint questions. If I turn to page 606 here, checkpoint questions are at the bottom of the page. So they're good for your understanding of the EVA computation and questions revolving around it. So take a moment and please go through those. They help in our understanding of those particular computations. I also wanted to tell you sometimes I just noticed it here, hurdle rate, again, is similar to the company's minimum rate of return. So different terminology, depends on what company you were with. They may call it minimum rate of return, others may call it hurdle rate. So just be aware of that scenario. I saw that just on the question there. All right. And again, we're trying to use these to influence, right, our management's direction with these ratios. That's the goal here, to achieve the strategic goal of the company as they move forward. So that's the goal anyway. Whether they do it, I don't know. That's the challenge, right? So our next computation or section in Chapter 11 talks about transfer pricing. And this occurs quite often on this discussion that starts on page 607. Because of our decentralized organizations, we might be selling between divisions, right? Our product might be going to Division B because they use the same part that we make in Division A. And the goal here is, what's a fair transfer price? What should we charge our own division? We're one same company, right? And we don't want to hurt one division to the benefit of another. And that's the goal with this transfer pricing. Because each manager, right, each division manager is judged on return on investment or residual income. And if that number goes down because of our sales intercompany, that we won't have sales intercompany, right? There would be no advantage for some division managers to sell between each other, and we certainly don't want that. So the author talks about the buying division versus the selling, right? If I'm buying from another division, that's a cost to me, so that's why it influences my bottom line. And if I sell to another division, right, that's revenue to me. And therefore, again, that selling price is critical to my performance overall, or profits, as it says here. Both these influences the profits of the divisions. And the author talks about three methods, right? Three methods to do that. And they're looking at market price, cost-based price transfer, or negotiated. Market price is the easiest. It's whatever the price was selling the product outside of the company. Whatever that price is, that's the price. So it's always determined, it's always known, and if it changes outside, it changes internally, right? So that's why it's nice, it's easy. And there's, again, if that is always the case, there's minimal conflict between division managers. And that's what we want. We don't want a conflict between our divisions. The next one is simply a cost plus transfer. And in other words, cost is always product cost, right? And so when we come up with cost here, we're really looking at the sum of direct materials, direct labor, and overhead. And that cost is marked up a certain percentage, and once I have that, whatever the cost is, I can determine a fair selling price, right, with a little bit of markup. So that's our second choice. And then finally, we have the negotiated transfer, and again, this is what both divisions agree upon. Obviously, this is tougher to come up with. It also poses the possibility of more conflict between divisions. And is most often used when we don't have a market price, when there is no market price. So there are certain products, even like consider Boeing, I'm sure there are parts in their airplanes that they do not outsource to anybody, and they only sell it within their internal divisions. So because of secrecy, trademarks, that sort of thing. So that's what we're up against, and mainly the reason why we have to then negotiate a price between divisions. So there is a discussion on those three. You can review that on your own. And they have a pretty good example. The one that we're going to concentrate on is negotiated transfer pricing. And here, what we're looking for is a range, a bargaining range for pricing. Again, we want to be fair between the divisions. So the minimum, the author wants to use the word floor. The maximum range or price range that the author wants to use is called ceiling. So those are the two terms that we want to use. And they talk about who sets the floor and who sets the ceiling. And I'm not sure if I see that here. Well, let's just put it on here anyway. Let's start with the maximum. The buyer sets the max, the ceiling. The minimum sets the floor, or the seller sets the floor, right? So what is the minimum charge? The seller sets that. The max, the buyer sets that. So you do need to know that. I know it seems simplistic, but we do need to know that for the multiple choice questions. On page 609, example 4, talks about how to calculate this transfer price when there isn't, in all cases, a market. Well, this one does have a market. So let's just kind of take this one. Example 4 is on the bottom of page 609 and goes into page 610. So if you could turn there, that would be awesome. That says here Alpha produces the CB117 model, and that can be used by Delta in its production. So in this case, alpha is the seller. Alpha is the seller. Delta is the buyer, because they can use it in their production, right? And they found that they can sell it to market in this particular case, which is $14. And then they also talk about full cost. Now, this definition we haven't used in a while. Full cost means direct material plus direct labor plus variable overhead plus fixed overhead. So there is a distinction in overhead between variable and fixed. Now, from cost, remember, variable would be that particular cost item that changes with different units of production. Fixed cost means it doesn't change, right? It's constant no matter if I make 1 unit or if I make 10, 20, 100, the fixed cost does not change. So we're assuming that this fixed cost total is $9. So there's a series of questions now depending on if it's a market price we will use, if it's a cost plus method or negotiated. So in question 1, if Omni has a transfer pricing policy that requires transfer at full cost, what would the transfer price be? And would Alpha and Delta choose to transfer at that price? So in this particular example, let's go to answer to question 1. The full cost was 9, right? And does Delta remember is the buyer, would be delighted with that price, right? Because it's much lower than the $14 market price. But Alpha, the seller, would not be. They're not making any money at selling it or transferring at 9. So obviously then the sale would not occur, right? There's no way Alpha would be doing that particular method. So in question 2, it says, if Omni has a transfer policy that requires transfer at market price, what would the transfer price be? Well, again, if it's market price, $14 is set. Well, Delta's used to paying 14. Alpha is used to selling it for 14. Neither would be worse off, right? So we certainly could decide at that point to use 14. And that's the easiest method. It's market price. But then they talk about a negotiated price. It says here, Alpha could avoid $3 of selling expense. And in this case, selling expense means what? Probably advertising, marketing, maybe a commission. There's no commission on sales between divisions. Because it's an automatic, there's nothing a salesperson can really gain or lose by selling to that person. So we're saving something. So now we can negotiate a slightly lower price than the 14 because the seller, which is Alpha, they can save at least $3 here. So at this point now, I should be able to negotiate a price somewhere between 14 and 11, right? So the floor, right, which is set by the seller, in this case would be 11. The ceiling, and again, the reason I'm going through this is that it's on the test. You got to know who's the ceiling person and who's the floor person. The buyer is the ceiling person, and the max they would be willing to pay would be 14. So obviously then, somewhere in this range, that we could negotiate a price. So that's the example in the book of all three methods, and just kind of an overview before we start our particular problem on this. So hopefully that's a good summary. The book does not give a lot of examples regarding transfer pricing, so there's not a lot of opportunity to practice this kind of computation, but hopefully it will come together as we go through our problem here today. So let's pause at the present time, and we'll come back and do one problem yet quick. Can't get to my screen. Here we go. All right. For problem 33, it says, which division sets the maximum transfer price? And then what would that price be? So guys at home, what do you think? Who sets it? We have two divisions, motel and furniture. Yeah, very good, Carla. Excellent. It's the motel division. And what's the transfer price, Carla? Excellent. Perfect. 40. Perfect. Sandy, who's obviously, and who sets the minimum? Yeah, furniture sets the minimum price. So I'm going to put right next to their names buyer, right, and seller sets the minimum. And what is the minimum price that the seller is going to want to sell it for? And the additional information we need is this furniture company can sell all that they make. They can sell all that they can make. So in this case, is there any incentive for the seller to sell it at a less cost than or price than 40? And basically, what guys, the answer is no. 40, exactly, Allison. 40 is the same floor amount. So in this case, because the seller can sell all they make, and also there is no difference because there is no cost savings anywhere. In our example, we had the $3 associated with an intercompany sale, and that just doesn't exist with this problem. So the second question says, what is the full cost transfer price? And that's given to us, which is what amount, guys? Yeah, 29. Excellent, guys. 29 is the full cost. And just remember, full cost means direct materials, direct labor, variable overhead, and fixed overhead. Perfect. Excellent. Question 3 then says, do you think the transfer will occur at full cost? And the answer is what, guys? Actually, it's no. Actually, it's no, right, Sandy? Full cost is 29. There's no reason for me to sell it at 29 when I can make 40. So in this case, no. Can sell and make a profit at $40. If I transferred it at 29, the seller would be hurt by that particular decision because I can make 40. Why would I sell it for 29? So that's kind of the analysis here. Good, thanks, Sandy, that we have to be aware of. So does it matter whether the transfer price, the transfer takes place at the minimum or max? And again, it's a kind of a silly question. No, they are the same. $40, right? So there is no benefit. There is no difference between them, so it doesn't matter. So that was kind of somewhat of a bust kind of a problem. So then they use the same information here on problem 33, 34, and then go to problem 35 on page 636, and something changes. So take a look at problem 35. Take a minute here to read the problem. And the difference is something called excess capacity. What does excess capacity mean, guys, when you get a chance? What does excess capacity mean? Actually, Allison, it's kind of the opposite. They can sell, their capacity is 50,000. They're selling 40 at the present. So what excess capacity means is that we have equipment that is idle, not doing anything. And we have the ability to produce 10,000 more units. So I'm currently producing 40. I have the ability to produce 50. And that's going to create a different scenario here now. So we are looking at this. One more item. They say that the variable costs equal $14. Variable cost equal 14. What three items are in variable cost, guys? What three items are in variable cost? Yep, direct material, labor, good, Carla. Which kind of overhead? Obviously. Yeah, variable overhead. So that's what we're adding up here. And the sum of those three, I'm going to put that down here. Let me change color. Is direct material plus direct labor plus variable overhead. Because on some problems, they may not just give you the dollar amount of 14 in this case. They might give you material is 5, labor is 5, and variable overhead is 4. What is missing? What is missing is the fixed overhead, right? So that is not relevant because that fixed cost, whether I make the 10,000 or don't make the 10,000 for the buyer, has no change on my cost. So fixed overhead is ignored in this particular case. So we again have the max and min question. The maximum is set by the buyer, which is motel. The seller, which is the furniture company, sets the floor, right? The minimum price. So this is the floor. The minimum, the max is the ceiling. So guys, who sets, or what is the amount for the ceiling now at this point? What's the max that the buyer is willing to pay? Excellent. Very good, Allison. Yep, $40. So let's put that in. That's the max price. Now, since we have an excess capacity, we have the ability to sell our 10,000 units to the motel division, and therefore it's not 40 is not the floor anymore, it's actually 14. If I'm the producer, if I'm making these dressers, if I can get 15, 16, I'm making a profit on those units. Because otherwise, my fixed overhead is there anyway. All I have to do is cover, if we can use that term, cover the variable costs. In other words, set a selling price above the variable cost of some amount. $1 above, $2 above, it doesn't matter. Whatever that is, cover that variable cost, I'm good. I make more money. So I can profit by doing this. So, in question 3 then, it says, suppose the division agrees on a transfer price of $35. Now, $35 fits in the range. So they're looking at a $35 transfer price. And that seems good, right? It fits between the 14 and the 40. So both the seller would benefit as well as the buyer would benefit. So in this case, $35 would be a good transfer price. It's within the range, the upper and lower range. And that's kind of the analysis that we want to get to here. So what is their bottom line increase in profits for the seller, which is the furniture company? Well, I'm getting a selling price of $35. I have costs of $14 that are variable. That means on those I'm making $21, right? And I have to buy, or excuse me, sell 10,000 to my division, which gives me a $210,000 profit. So my profit's going to go up 210 by simply selling internally using the excess capacity, right? So I'm using the excess capacity, which is always good. So my machines are not idle sometime through the year. The buyer makes what? They make $5. Well, excuse me. They normally buy it for $40. But now I can buy it for $35. I save 5 times 10,000 units that I'm buying. I'm making 50,000. So in this particular case, both companies are excited to have this opportunity to make more money. The negotiated price is a good price, somewhere within the range. And for the company as a whole, they would make $260,000 then additional profit by selling it internally. So if you want to look at this 260 another way, remember, I'm not buying from an outside supplier, right, any longer. So that savings is actually 400,000 in less expense going outside of the company as a whole, right? But remember, I had to spend $14 in materials and labor and overhead. So this yields 140,000. The net of those two obviously is the 260. So if you want to look at it that way, that's showing cash flow wise what my company as a whole will benefit by not going to an outside person to buy that material or those dressers in this example. So this is the more complex type of problem that you'll encounter on some of your exercises and problems and so forth. What makes this a little more complicated, one, it's negotiated, right? And two, it has to deal with excess capacity. And the author within Chapter 11 really doesn't address that very well with the example in Exercise 4. So this is where this is a good problem to keep handy and use as you study for those exercises, problems, and exams. All right. Are there some final questions? I know we kind of went through that rather quickly. We'll review it again on Tuesday along with our summary or overview of Chapter 11 and to get ready for the exam on next week, Thursday. Allison, you're okay? Sandy, Carla? Eric, you're all right? Oh, Sydney, I forgot about you. Sorry. All right, guys. I'll save the notes for today. You'll have those information if you did miss some of the numbers as we were going through it. But I'm going to end at this point, and we'll pick up on some, I guess, more definitions called the balance scorecard on Tuesday. We got to cover that yet. And then within that balance scorecard is a couple more computations, velocity, and I think there is, velocity and, what's the opposite of velocity? I'm drawing a blank. Oh, MCE, cycle time, velocity at MCE, we got to cover yet on Tuesday. Again, very simple computations. All right, guys. You guys have a safe weekend, and I hope the snow melts.
I do too.